In this example, we will work out the compound growth rates. We've got two separate types of problems. The first problem is when we're given a number of different growth rates over time. And the second problem is when we are given a start value and end value, and we asked to work out the compound growth rate. So can you start by downloading the start file? Right. Okay, so right, in the first problem, we are given a company's annual growth rates and profits, right? So 5%, 8%, 12%, 10%, right? What we asked is we asked to work out the geometric mean of these growth rates. We actually asked what is the compound growth rate that if it stayed the same over 4 years, we would arrive at the same end value of the company's profits. Right, in this case, we're going to use the geomean function. Right, by the way, you may be tempted just to add the 5%, 8%, 12%, and 10% up and divide it by 4, but that wouldn't give us the right answer. It's the nature of the mathematics. Okay, so here we go. What I'm going to do, I'm going to copy this down and paste it. Okay, so the way we're going to solve this, we can use the geomean function, right? And what I'm going to do is I'm going to say, in the first case, I need to add 1 to each of these growth rates. So we go 1 plus 5% equals 1 plus 8%, 1 plus 12%, 1 plus, oops. Right. So what we've done, we've added 1 to each of these growth rates. And now what we're going to do is we're going to use the geomean function, and we select the values. Okay, and that gives us 1.08. What we now need to do to get the correct value, we're going to subtract 1. Right, and we're going to use 2 decimal places. Okay, so it basically means that, if the company's growth rates was if the company's growth rate was 8.72% for every year for 4 years, the company's profits would be the same as if the company had grown at 5% the first year, 8% in the second, 12% the third, and 10% in the last, right? So that's the average compound growth rate. In the second type of problem, what we've got is I give you a start and end value, right? And we want to know what the compound growth rate was given the start and end value. Now, in this type of problem, what we're going to do is we're going to use the rate function, right? So we're going to use the rate function, and here goes. First thing I'm going to do, PV. Now note, in Excel, you need to make this value negative. So we have a condo in Bangkok. Its price is 35,000 in January 2020. And in 3 years, in 2020, the price is 45,000. So the PV, the starting value, right? No, it has to be negative, right? Minus 35. Future value, right? This is the ending value, 45,000. Now, over here, NPER, this is the number of time periods. Now, in this case, we're dealing in years. We're going from January 2020 to January 2023. So that's 3 years. 3. Okay. So what I'm going to do here, the compound growth rate is equal to rate, open bracket. The first thing that they want is the number of periods. So it grew in 3 years. So it's three periods, comma. There's no regular repetitive payment. So just going to leave that blank, so comma, comma. Right, now it wants the present value, the starting value right? So click on your 35, and then it wants the ending value. You don't have to put a type or guess. You can just push enter. 9%, and let's make that 2 decimal places. And there we have it. Right, I hope you found that interesting, and I'll see you in the next video.